64, here we go. So remember, we had our functions review. Remember, we had our polynomials. And what did that would be our constant, our linear. We would have quadratic and cubic. So those are the ones we've covered there. So our constant, right, is just going to be a straight line like that. Our linear goes either up or down. Our quadratic, and we're normally within first quadrant or the first and the fourth. Quadratic, right, we've got projectile like this, or it could be something like this, who knows, okay, but that's quadratic. And then we had cubic. Our cubic could be, looks like that, or it looks like that. Okay, so that's something you need to remember. What do we call, what's one value that we look at that tells us which way the graph is going? What letter does it usually have? It's letter A. And we call it the LC, the leading coefficient. Do you remember that? Is that so? This one would be A is positive, right? If A is positive, you know that's going that way. If A is negative, you know that the function is going to go down. With a quadratic, which way is this? This would be A is. If it's opening down like this, A is negative, A is positive. So that's something to review. If a linear, if this is going up, A is positive, A is negative. That's something, that's the leading coefficient. And most of the questions are going to be a bit like somewhat general, some regressions here and there where I give you the points, but just remember what we're talking about, right? So I'm going to leave that at that. Then we had exponential and logarithmic. Exponential logarithmic here. I'm going to be biased. I am focusing on word problems here because most of the time they're around that context. So for exponential, what do we know about exponential functions? They never touch which one? Which axis? Do you have that on your study sheet? It never touches the x-axis. Okay. We call that the asymptote. The plane and the asymptote, right? So it never touches, never crosses. So that is a hint. That's a hint when you're sometimes not sure, hey, is this an exponential logarithmic? If it crosses, you know it can't be exponential. So it either goes like this or it goes the other way. I'll do it under here because there's two distinct cases for this. So still doesn't touch, right? And the asymptote is y is equal to 0, by the way. I've never seen them ask you for it, but that's what it is. It's basically the x-axis, so y is equal to 0. And another one could go like this. It starts somewhere here. It does have a y-intercept. but then it goes like this and it never touches. It just never touches. How do we know the difference here? In general, the exponential looks like this. Y is equal to a b to the x. And the y-intercept here is always going to be 0a, always. So whatever a here, that's going to guarantee you the y-intercept. 0a is right there. If b is less than 1, sorry, this one is greater than 1 because it's increasing. Get your act together, right? I'm just freestyling this, okay? So I'm b is greater than 1, you will have an increasing function, right? So that's what's happening here. You guarantee that it's going to go up. How does this helpful? If I give an equation where this is 1,000, a is 1,000, and b is greater than 1, you know that your window, right? You're going to have to go bigger than 1,000 here for y max, right? You're going to have to increase that because you might not even see anything. Help, zoom fit can sometimes help you. If you're doing a regression, zoom stat, but make sure plot 1 is turned on. Things like that can help you out. This one here, this is 0a still. It's up here, but b is going to be less than 1. B is less than 1, then this is happening here. Okay. Logarithmic. How does a log look like? It looks like this. A plus b ln x. It could also be log. I will do that because you might be like, well, where is that coming from? Sometimes the question could have log x there, so it shouldn't surprise you. And if you could imagine this flipping, right? This flipping, that's what this is. So I will actually do it like this. And in this case, this is your asymptote here. Asymptote, and that's x is equal to 0. Never crosses. So depending on the context, sometimes negatives are allowed. Okay, it will come here, cross the x-axis. It crosses here, but that point is not given to us by this. What is given to us? A is still helpful here. It's 1a. Okay, it's 1a is always going to be part of your graph. That's a good one to include. So you know, hey, that's, so in this case, b has to be greater than 0. Then you have an increasing function. You can write that down as well, increasing. I'll do another one here. This is still my asymptote. You would come from over here. Uh, 1a is still there. B here would be less than 0. That's negative. Okay, if you need to tell yourself B is negative, B is positive, you go for it. Right? You do what you need to do to make sense of this. I'm just trying to help you. This, okay, it is very likely that you probably end here. Okay, this can be used. Use your calculator to figure that one out. Okay. Use your calculator to figure out the x-intercept. It's very likely that you can't be in the negatives. Okay. Quite often, can I just say this? Time is often in the y-axis. So that's what makes this one confusing at times, but you just go by what they give you. Okay? You don't change the course because of that. for exponentials, I don't think I'll use this. I'll use the backside for this. And this is just an overview of exponentials right now. Let's go to 65, if you would. Regressions for exponentials. A population of, let's say, 1,000 has a doubling time of, let's say, 20 years. How would you figure out the equation? What would you do here? Doubling time is exponential, by the way. You can highlight this part. Exponential for sure. What does that mean, a doubling time of 20 years? That every 20 years, your population, your previous populations doubles. That's what that means. So we go time and population, X, Y. What do we start with? I'm interested. Yeah, thank you, Lily. 0 times 0, you've got 1,000. This is probably one of the biggest reasons you get this wrong, is you start at 0. Start, okay? This point right here is your starting point. And then you're saying, right, 20 years later, you literally add your doubling time. This is gonna double. So you got 2,000. Another 20 years go by. Hey, the doubling time could be weird numbers, okay? It could be 1.05 days. It could be 23.45 minutes. It could be anything. It could be 150 years. It doesn't matter. So you go to 40, then this will double again. So the doubling happens to the population, to the amount of money, what have you, okay? You type this into L1, L2, and boom, you're good to go. Now I could ask you, hey, how many people would you expect after 160 years? I could ask you anything I wanted. You go for it. Another one. This is example with equation. Let's say the population over time of a little town is, let's say, 500 people. I'm done after this, I promise. What does this number represent? If I ever asked you, you would say A, that's A. No, within the context. Initial, in this case, population. You know that if you were to graph this, 0, 500 would be on there. When time is 0, 500, that's your initial population. That's also known as the y-intercept. Okay. What does this mean? Well, b is greater than 1. It'll be increasing by every, I think I'm going to make this years. How much am I going up by every year? It lies in here, right? You take 1 away from this times 100. So it's by 1.5% per year. You ready for this one? This is my grand finale and then your mock test time. What is the doubling time? What is the doubling time of this town? How long does it take to double your population? You let Y2 be? Yeah, go ahead. What did you start with? 500? So whatever this is, you double it and you plug it in here. So this would be 2 times 500. Right? That's 1,000. And then you're going to go second, trace, intersect. So you're essentially finding, if this were the graph and it starts here at 500 and it does this, this is 0, 500, you're going to go to 1,000 and draw this line. If your initial population is 20,000, then you would go times 2, 40,000, right? So this is the 1,000 line. You figure out the time, okay? You're essentially saying, hey, what time, how long will it take to double my population? That time doesn't change. It will double your previous amount every X number of years that you're finding, okay? I'm done, guys. Mock test time.